Hello. In this episode, I'm going to explain how to evaluate a 2D tensile test. In the previous episode, I've shown you how to prepare, capture, and import a specimen. You can see in this project an imported 2D tensile test with the applied stochastic pattern. GOM Correlate has switched automatically to the inspection workspace. You find here all the tools you need for the evaluation. The first function you need is the surface component. During the creation of the surface component, the software finds squared facets in the acquired images. The software identifies the facets by the stochastic pattern structure. Please find more detailed information for the surface component in the direct help. The software automatically determines the surface component over all available data. However, you can also create a manual selection. This is sometimes necessary to avoid artifacts on borders or if you want to evaluate only certain regions of your specimen. Click Deselect All to reset the automatically determined selection. Click Now, select Deselect Polygon. Draw a polygon around the specimen. Finish the selection via right mouse button. Keep the right mouse button pressed and move it over the plus sign. If you now release the right mouse button, the software creates the selection. All data within the polygon is now selected and is computed automatically. To deselect the hole in the middle, click Select Deselect Circle. Again, finish the deselection with the right mouse button. Choose now minus for the deselection. Click Now Create and Close to create the surface component and close the dialog. The software computes the surface component now for all available stages automatically. You can see now only 2D information as the data was captured with only one camera. The software automatically positions the coordinate system in the center of the image. However, you can also change the position of the coordinate system via alignment. Click on Create Alignment 3 to 1. Click 3 points for a Z-plane with Ctrl and the left mouse button. Click also 2 points for the X line and 1 point for Y. You can see that the Y-axis is defined along the tangent direction and the X-axis is defined perpendicular to the tangent direction. You can find the alignment now in the Overview Explorer. You can also switch back to the original alignment at any point. You are now able to create checks on the surface component. The button Check All Visible Actual Elements offers you the checks which you can create on the surface component. Please remember, if you would like to use displacements, velocities or accelerations, you have to define the scale of the specimen. The scaling is for strain checks not important as the results are expressed in percentage independently from the real dimension. Click on Epsilon Y. The software automatically computes and displays the full field epsilon y strain on the selected stage. You can choose the strain representation and whether you would like to calculate the strain against a fixed value or against reference stage. Again, if you would like to know more about the checks, please open the direct help for more information. If you click OK, the software calculates the checks throughout all stages in the timeline. The legend on the right side gives you now an indication of the strain values. The current scaling is based on each individual stage. You can adjust the legend to a fixed value by clicking on the upper or lower limit. You can also click with the right mouse button on the legend and choose Scaling All Visible Stages. The software scales now the legend towards the highest strain value of the check. You have determined the epsilon strain along the tangent direction. You can also use epsilon x to determine the strain perpendicular to the tangent direction. You can get also more discrete values for the strain with the deviation labels. Press the Ctrl key to get a preview and create the label with a left mouse click. You can abort the function with a right mouse click. You can document the results at any point with a report page. Just click on Create Report Page. Choose now your desired template type and also the format. You can also choose if the report should contain only an image or a video or a flipbook. If you click on Edit Content, you can readjust the position of the content in the 3D view by having the dimension of the report page. You have now the report page as an element in the Overview Explorer. You can also switch to the Report workspace, where you can find further options for report pages, such as PDF export. Please watch episode 6 for further information regarding report pages. You can also use a full field check on sections. Just click on Pointwise Inspection and choose Section and Viewing Direction. Click 2 points for your desired direction. You can now choose Epsilon Y again. In addition, you can also display the section in a diagram. In the next episode, I'm going to show you how to do a simple inspection on 3D surface components.